dès le début. Donc, hello, bonjour à tous. Je suis ravie d'être avec vous. Merci de m'avoir invité. Je suis ravie de rencontrer les apiculteurs français à nouveau. Ça fait 7 ans. Quand je l'ai rencontré, et puis j'en ai des très bons souvenirs de nos rencontres. Ce soir, je voudrais vous parler des Tropilaelaps, bien sûr. Peut-être que vous avez lu les derniers rapports. Alors, en Turquie, nous sommes en alerte rouge. Et les apiculteurs turcs sont très inquiets. Ils nous assaillent des questions. Mais je suis également vice-présidente du projet COLOSS. Et en fait, je suis à la tête du comité scientifique pour la santé des abeilles. Et je travaille aussi sur les pathogènes, sur les parasites, que ce soit le Tropilaelaps, le Varroa ou d'autres ravageurs qui attaquent les abeilles mellifères. Donc, je voudrais montrer une vidéo il y a 2 ans, en fait, en avril, le 3 avril 2023. J'ai produit une vidéo sur ma chaîne YouTube pour prévenir, pour alerter.
Turkey is a danger country for Tropilaelaps, or Turkey is the suitable country for Tropilaelaps biology. Yes, unfortunately, Turkey is a very good place for Tropilaelaps because migratory beekeeping is very common and popular, means that Tropilaelaps can move to another places easily. And another point is wintering area near the seaside is very long, approximately 2,000 kilometers. So most of the colonies move to the wintering area. Wintering area means the climate is warm, and also the larva production continue the whole year. So this means Tropilaelaps would be very happy to reproduce herself. So Tropilaelaps would have no problem in Turkey. That's why we are in red alarm now. And the first warning for our beekeepers was that please don't move your colonies near seaside or the hot area or warm area, warm region, especially southern of Turkey and the west part of Turkey. And the second warning for them, please do your beekeeping activities in your own place, not move the colonies, not migrate with your colonies during the season, because in migratory beekeeping techniques, you should reproduce your colonies all the time to follow nectar. You refresh your colonies, so you are always on production. And the 2 points are very danger for us in Turkey, for Turkish beekeepers, when we come across with Tropilaelaps. she can distribute it very, very fast. So I ask you to watch my YouTube video 2 years ago to warn Turkish beekeepers. Please let me know if you couldn't hear me with YouTube video. YouTube video is Turkish, but I will translate it for you. Okay.
2023 Pazar. Asli ÖZKIRIM'le Arı'dan konuşalım YouTube kanalıma hepiniz hoş geldiniz. Bu kanal
Today
bilimsel gelişmeleri
is
anında
Sunday.
Ve bilgileri iletmek.
Sunday early in the morning, and one day before, Tropilaelaps reported in Kazakhstan and Russia, not Georgia yet.
Amacıyla kuruldu. İşte tam da bu amaçla pazar sabahı köründe sizlerle buluşmak istedim. Çünkü konumuz acil. Konu başlığımız Tropilaelaps. Amacım asla.
Yeah. And I introduced the title of the speak, and I said, this issue is very urgent, and the title is Tropilaelaps.
Sizlere yeni bir ders eklemek, başınızı ağrıtmak değil. Ama tüm dünya alarma geçti bu yeni akar konusunda.
Yeah, and I informed them about the alarming countries for about this mite, because in COLOSS Association, we have more than 2,000 researchers from 125 countries, and we shared our knowledge about colony losses, monitoring, Varroa, and other diseases, so we can keep in touch with between us and also follow the issues like Tropilaelaps.
Akar yeni de değil. Bize ait bir akar da değil.
Yeah, Tropilaelaps is not a parasite of Apis mellifera. Tropilaelaps, original host of Tropilaelaps is Apis cerana. So Tropilaelaps comes from Asia, an Asian part of the beekeeping area. So why is she here now, or why can we find Tropilaelaps in Russia? Because the southern area of the world, China, Korea, and Asia part, more warmer than the north part, but we think that climate change is the main cause of this moving, because the original area is warmer than the new area for Tropilaelaps. And there is a typical story between host and parasites. Please remember COVID. COVID virus is not belongs to human. The original host of COVID virus are another mammalian. I couldn't remember the English name of the mammalian, but like birds. Please help me for translation.
Bat.
Thank you very much. And when a parasite lost their original host and randomly moved to another host, but similar host, they would be very aggressive to be survived. Otherwise, they afraid that they collapse. They cannot be survived. That's why they cannot continue their life as a parasite. They behave like a pathogen. That's why they would be more aggressive. So in pandemia, COVID-19 behave like a pathogen, although all viruses are parasite, because virus change their host. So Tropilaelaps behave similar like this. Because of the climate change and the northern part of the world warmer and warmer, so this place would be more suitable than the past the Korean part or Chinese part, because they are also warmer than previous time. So Tropilaelaps change per host from Apis cerana to Apis mellifera. They are similar, but although they are similar, Tropilaelaps in a panic and then try to adapt the new organisms for her. The new organisms is Apis mellifera, European honeybee races. So similarity is a big disadvantage for us because, okay, Apis cerana is totally different, but it is Apis. So it's bees, it's honeybee. So Tropilaelaps in new area, Tropilaelaps will be more aggressive, more invasive, and more danger for our honeybees. But in China and Korea, they mostly like adapt each other, host and parasites. And I would like to inform you about the host and parasites relationship and this approach to understand, in order to understand Tropilaelaps biology. Yeah. And Apis cerana and Apis mellifera, they are in the same genus, and Tropilaelaps and Varroa, they are both mites, but there are some differences and also similarities between them. And the main differences is the size. Varroa is bigger and wider than Tropilaelaps. And also Turkish beekeepers confused about Tropilaelaps and also the other organisms. Several years ago in colonies, they know them, the other organisms, and I will talk about later. Yeah, and you can see the map, the original country and of the countries of the Tropilaelaps in previous years, and because of the climate change, Tropilaelaps migrate to the north part, unfortunately. Yeah, and there is no report officially, but we collaborate with some scientists from Iran, and scientists report that, yes, we heard about Tropilaelaps from beekeepers, but we couldn't catch the case exactly yet. So, so far, we know that Tropilaelaps in Uzbekistan, Kazakhstan, Russia, and Georgia. Georgia is very close to Turkey and Caucasian border of Turkey. And this location is the Turkish side. This location protected by government for gene protection center, because this location is special for Apis mellifera caucasica. Apis mellifera caucasica is endemic for Turkey, and this area isolated from
Pour de l'abeille qui est endémique en Turquie, et il est interdit d'importer certaines abeilles, et puis on évite effectivement, elle a dit, l'apiculture migratoire, le transhumance, j'imagine. Et il faut se dire qu'il y a quand même des montagnes qui empêchent potentiellement des migrations un peu sauvages des abeilles. Donc, nous savons qu'il n'y a pas forcément un passage par les montagnes caucases, mais l'importation des reines ou le transport des reines peut suffire.
Yes, and I was talking about the major problem or critical points for Turkish beekeeping. Why Tropilaelaps would be very happy in Turkey?
Pourquoi, effectivement, les conditions des pratiques apicoles en Turquie fourniront des conditions parfaites pour le Tropilaelaps.
Means movement of colonies and also always
Des
and always
mouvements de colonies.
This is the basic information for Tropilaelaps.
Voilà ce qu'il faut savoir. Ce sont des renseignements de base.
Tropilaelaps and Varroa destructor together very clear and
Il y a
easily
des différences entre Tropilaelaps et le Varroa destructor. Et on voit rapidement, et puis le Tropilaelaps va être uniquement sur le couvain. Alors, le Varroa va être sur les abeilles et on peut le voir sur les fonds, sur des ruches. Sur le couvain et dans les alvéoles, bien sûr. Quand les abeilles émergent d'une cellule operculée, on voit les Tropilaelaps sortir avec l'abeille. En fait, et dans mon expérience, dans 30 secondes, en fait, ils sont partis ailleurs pour retrouver d'autres couvains. Quand je l'ai vu en premier, je ne me suis même pas rendu compte que c'était des Tropilaelaps. Donc, n'imaginez pas un quart de seconde que c'est facile de les voir et de les identifier. Quand on les regarde sur une vidéo, ça semble facile, mais dans la vie réelle, c'est moins le cas.
So, another organisms we called as
donc, il y a un autre organisme qui est le pou de l'abeille.
Tropilaelaps and Varroa mites, but this is insects and she feeds on
Tropilaelaps et le Varroa sont des acariens, mais ce pou est un insecte.
Yes, comb foundation, beeswax. She cannot feed on larvae or adult bees, but Varroa and Tropilaelaps, they are feeding on bees. Varroa, both larvae and adult bees, but Tropilaelaps is feeding on only larvae and pupa of honeybees. Yeah. So in this part, I'm explaining that if the brood production continue in your hives, means that Tropilaelaps may be alive in your hive, because Tropilaelaps cannot be survive on adult honeybees. But biologically, okay, she can be survived sometime without feeding on adult bees. And it takes only 3 days. So after 3 days, she cannot be survived any longer, approximately 3 days. So beekeepers, when the beekeepers get this information, thinks that, okay, it's easy. If we use queen caging method and broodless period for only 3 days, we can escape from Tropilaelaps. But unfortunately, the solution is not easy like that, because Tropilaelaps move very quickly, and also Tropilaelaps don't need to be mated for reproduce herself. Varroa needs to be mated, but Tropilaelaps, like drone bees, can produce by parthenogenesis. So the generation is very, very quick, fast, and highly, 5 times than Varroa. So this is the critical point for beekeepers to control it.
Yavru nereye geçiyor? Bu geçiş sırasında sadece ergin arıları kullanıyor. Ama ergin arılar üzerinden kaç saat canlı kalabiliyor? Hadi 72 saat. 72 saat ergin arı üzerinde canlı kalıp daha sonra beslenemediği için açlıktan ölüyor. Götürüyoruz. Ve bu bölgelerde...
Yeah, so I would like to show you the beekeepers movement in Turkey. Please look at the map. So the red sign is go through the west part and the blue signs back to the east part because spring is starting from the west part and they move to the east part and the green
Et
locations
vers
are
l'est, en fait, avec des mouvements 3 fois par an.
75% of colonies
Et
move to the
le
wintering
littoral,
area for
les
wintertime.
zones
So
vertes
in
dont je vous
Turkish
parlais
beekeeping culture, honeybees cannot sleep very well
sont
during winter because the
utilisées.
beekeepers think that they must their colonies in warm conditions to protect them. So we are trying to convince them you don't need to keep the bees in warm conditions because not only for Tropilaelaps, but also all microorganisms, all pathogens like to warm conditions as well. So the weather conditions is very important for beekeepers, and please keep your colonies in cold conditions, cold winter conditions during the winter time. And also nosema spores and the chalkwood fungi spores and the varroa and the Tropilaelaps cannot be survived in the cold conditions as well. And also the you should stop the brood larvae, yes, brood production during the winter. This is the main point for Turkey. And I would like to show you the races and ecotypes of in Turkey. So this is advantage for Tropilaelaps because as the beginning, as I told you that host and parasites relationship very important for the parasites improvement, development. But parasites, in any case, parasites has to adapt their host. So in one country, if there are many ecotypes or different races, means that parasites has to adapt different races or ecotypes. So it takes some time to for this adaptation. This is advantage for us because in Turkey, we have 5 different ecotypes and 2 different races. Another problem, yeah, another problem in Turkey, we have millions of colonies, so beekeepers keep the colonies very closely, and 1 kilometer square, there are many colonies together, especially in wintering areas. So this situation also very suitable for Tropilaelaps. This is another point. And also Turkish beekeepers cover the colonies to protect them from cold weather. As I told you before, this is also very suitable conditions for Tropilaelaps. Please don't forget that. Tropilaelaps, Tropilaelaps comes from tropic area. So she likes the high heat and the warm conditions very much. For instance, Varroa cannot be resistant to high heat. So when sometimes we use the high amount of heat shock for Varroa treatment. But for Tropilaelaps is more resistant to the high heat and warm conditions. Please don't forget this information. And also I talked about during this part.
Genelde varroa mücadelesinde zaten çok etkin ürünler kullanıyoruz.
Yeah. In this part, I was talking about what shall we do when the Tropilaelaps come to the Turkey. What is the first step we have to do? Nowadays, some Turkish beekeepers don't like this suggestion or advice but unfortunately, I have to say that when you find the Tropilaelaps the first time, please burn your colony, because this is like a pandemic, and we shouldn't think about the treatment of the Tropilaelaps at the first step. And some of the Turkish beekeepers angry with me, unfortunately, but I'm a biologist. I love bees. That's why I suggest them to burn their colonies, because if we find the first time, means that distribution is very, very fast. So after reporting 1 or 2 location Tropilaelaps in Turkey, okay, the second step can come, and we can say that this is the treatment time. And what is the treatment of Tropilaelaps? Exactly the same with Varroa, but there's a little bit differences, the very few, very small differences, the Varroa treatment and Tropilaelaps treatment regarding their biology. Tropilaelaps reproduce themselves quicker than Varroa, more quickly than Varroa, and it will take only 5 and 6 days to reproduce themselves, and also there is parthenogenesis. So you should use long-term release product for Tropilaelaps treatment, and like oxalic acid, like formic acid, and like some veterinary products are very, very effective on Tropilaelaps, but they should enter the brood cells. And one chemical, organic or the synthetic chemical, it doesn't matter. One chemical can enter the brood cells, means that the chemical may have side effects on broods. So you also should protect your brood area. That's why for Tropilaelaps treatment, we don't want to use affect rapidly and evaporating system for Tropilaelaps. We prefer long and slowly effectiveness chemicals or organic materials for Tropilaelaps treatment. That's why we suggest, we offer Turkish beekeepers first step, burn, fire the colony and report, but I'm afraid they don't want to report it because they don't want to burn their colonies. That's why I'm always on the field and check the colonies. And the second step, please use the Varroa treatment techniques, pollen trap and drone brood area. You can create drone brood as a trap for Tropilaelaps, and then also sugar shaking, and also flumetrin or amitraz, commonly used in Turkey, but I would preferably suggest them using oxalic acid, but not the evaporation technique, by the gel form, a gel formula, by glycerin or chitosan. I will explain the formula later. But our first problem or our first main issue should be diagnosing of the Tropilaelaps. Because the first step directly depends on the diagnosis. That's why I would like to show you some diagnosing methods of the Tropilaelaps to you. So this is my, I don't want to, okay, sorry. This is the last part of my video, and I recommend the Turkish beekeepers that please collaborate with COLOSS and international work, and please help me in my field study. I'm saying the Turkish beekeepers, and I suggest them, please don't be afraid when your colonies live under the snow, because it's very healthy conditions for them, and snow can protect your colonies, don't worry. And please shut down, or please cover the colonies very well, because the up part of the hive should be warm. It's very important for bee colonies, and please cover the colonies very well, but the bottom part should be totally open. Why? Because the moisture level should be stable and not very high, especially for preventing protection of the chalk brood disease or nosema infection. And so you should open your hives, the bottom part during the winter, and the up part should be covered very, very carefully. So how can we diagnose the Tropilaelaps in our hives? Let me show you that. Sorry, here it is, the second one. This technique developed by my COLOSS friends and myself together, rapid brood decapping technique. First of all, can you see the video? Can you see?
Yes, we can.
Okay. So there are two research groups working on Tropilaelaps scientifically. I am keeping touch both of all of them because they are my friends. One, Jeffrey Williams, and they are working in America, United States, and Canada. But Canadian and United States American beekeeping is a little bit different from European beekeeping techniques, because they are doing beekeeping, not only producing honey. They focus on pollinating service. They use their colonies for pollination. But in any case, they are professional, and then for testing the Tropilaelaps. But they are looking for Tropilaelaps in debris, the bottom side or pollen platform of the hive. So, but as I explained you before, regarding the Tropilaelaps biology, Tropilaelaps feeding on larvae, and they move one brood cell to another brood cells. If you find them on the bottom part, means that they should be killed or dead to fall down the bottom side of the hive. So we think that we must looking for Tropilaelaps in brood cells, but they are not go out the brood cells at the same time. Different time they go out, and we cannot observe them. That's why we create this methodology, this technique with Alexander Zunov from North Macedonia, Yanesh Chen, and Marin from Zagreb. So, but we are working in Georgia with Irakli. Irakli is another scientist in Georgia, and they are studying on Tropilaelaps because we have no Tropilaelaps, thanks to God, not yet. So field study made in Georgia. So we create this video and we translate this video in different language. I'm sure in it's French. So I am translating this video also in Turkish, and I publish it in my Facebook, YouTube, and all web page to learn this diagnostic method to the beekeepers. So, okay, it's possible maybe to find the Tropilaelaps in debris in bottom part, but this technique is more efficient for Tropilaelaps detection. You can continue the translation for by reading the, you know, this is the English version. So by reading the instructions, you can continue the translation. If
Okay.
or
It will be okay, yeah.
okay, thank you. So the critical point is for materials, depilation wax strips. You can ask your wife if she's using it or not, because in Turkey, this is the cultural subject, that to share this information between Turkish beekeepers, they don't like to talk about this kind of women's stuff. But anyway, I advise them also using the top, I think in English it's topper, something like that, stick. But this is it is very important, the kind of the top, because some of them are damage the comb foundation. So this depilation wax strips is the more efficient stuff for this diagnosing method. You can ask your friend to help you for keep the mobile phone on top of the frame. Why we are using mobile phone? Because we record the 30 seconds of the Tropilaelaps moving. Otherwise, if you try to observe Tropilaelaps, one, you cannot distinguish, you cannot identify them because you are not familiar to her shape. Two, they are moving very quickly, so you cannot catch them efficiently. But if you take record, take video, and stop them, so after that, you can watch the video several of times, and also you can zoom the video, and you can distinguish, you can identify the Tropilaelaps easy. Yes, we focus on some pupae with black eyes and warm up the wax strip and stick on the frame. And please be gently, like a Frenchman. mark area with colony ID and start the video recording. Then rapidly remove the strip and 30 seconds continue to take the video. And please look at the red circles. Can you see the Tropilaelaps? And in 5 seconds, they are suddenly disappears. So you cannot see anything anymore. So the first 5 and 10 seconds, it's very important for the diagnosis. So I would suggest you in springtime for the first generation of your broods, please control your colonies and try to observe your colonies for Tropilaelaps, and you can use this method. It's very effective, and thank you to the Alexander Uzunov and his team, including me. And the last part of my presentation about Kytoset, this is my formula for Varroa. I'm biologist, I'm not veterinarian, so my priority is always protect bees, not the treatment directly. Okay, we need treatment, but my expertise area focus on to keep the biology welfare. So that's why I was working several years of the bee biology and the pathogens or parasites biology together and the adaptation. So that's why I focused on not only Varroa destructor treatment, but also the healing of wounds because of the Varroa bites. Because I know that when the first time Varroa bites honeybees, even if you hold down the Varroa, bites are there, and the wounds, the bites wounds, the major reason of the secondary infection, bacterial infection on honeybees. So you think that, okay, all Varroa drop down and you escape from Varroa, but you cannot be sure your honeybees surviving, because after Varroa fall down, like the knives take out, your honeybees losing some tissues and also get some bacteria from the hive, and at the end of the story, your bees dead again. So you think that you fight with Varroa, but you cannot keep your bees alive. So the start point is to search on the chitin layer of honeybees. Chitin is basically responsible for protecting the body of honeybees against external attacks. That's why the first damage of Varroa is on the chitin layer of the honeybees. So my hypothesis is, okay, Varroa harms honeybees not only by feeding, but also by the wounds it inflicts. Varroa bites cause a hole in the center of wound and also on larvae. So a chitin layer on larvae and adult bees as well together. And so Varroa and also Tropilaelaps in near future damage the chitin layer of adult or larval bees. So in the literature, I found some, I found some electron microscope photos of the Varroa bites. So after Varroa fall down, the bites, the wounds open to the air. And I was wondering that how long does it take to cover the wound healing of bites? This is the main question of my study. And that's why I was looking for a biological molecule very similar to kitten layer to cover the kitten layer, or to cover the Varroa bites wounds, or big hole of the Varroa. So I found the chitosan molecule. Chitosan is derivative of chitin by the acetylation. Chitosan like bones powder, chitin real bones. So this is metaphor, of course. Chitin layer is a chitin surface of the adult bees and larvae, but the chitosan is a powder and gets from some crustacea familia from the sea, or some molds, yeast have chitosan, and also all insects and mites have chitosan. So I search for chitosan, search on it. So then in the literature, I found that chitosan cannot be soluble in water. We cannot make a solution, chitosan solution with water. Chitosan only soluble in weak acids, organic acids. So the first time I read this article that chitosan cannot be soluble in water, you can make a solution only with organic acids. First, I thought that, okay, that's the formula, because we're already using organic acids against Varroa. So if we add chitosan in organic acids, maybe chitosan can cover the Varroa bites, and we can prevent the bacterial infection of secondary infection because of Varroa bites. That's why I set up the experiments, and my experiments and my study published in Journal of Apicultural Research, chitosan-based gel application on model bees for healing bite wounds caused by Varroa destructor. Because another point is, during my study, when I add chitosan into the oxalic acid, lactic acid, formic acid, uric acid, citric acid, different types of acids, the optimum solution can be made in oxalic acid. And oxalic acid, when I put into oxalic acid chitosan, oxalic acid change to liquid form, to the gel form. And then I made field study. And first I made cage experiments to measure the wound healing capacity of chitosan. And every day I took samples from the cage adult bees, and take the picture of them under the electron microscope. And also I made some field study in the colonies. So after complete my all studies in cage and also the field study, I get some interesting results with this solution, because chitosan or chitosan, I don't know how I can pronounce, chitosan can cover the Varroa bites with contact of chitosan and oxalic acid together. And if I leave the honeybees free without any application, these wounds, because of Varroa bites, these wounds healing takes 9 days. But with the help of chitosan, it takes only 2 days, 1.5 days, they cover the wounds, and the polymerization initiates, and rapidly the chitin layer repair itself. And the other interesting results, chitosan made oxalic acid in a gel form, so the effectiveness of oxalic acid more longer than oxalic acid evaporation or oxalic acid liquid form. And the effectiveness period, I measure the effectiveness period, it takes 27 days. So during the 27 days of the application, after the one application, during the 27 days, still Varroa mites fall down, and also the cover of the Varroa mites cover of the wounds sustainable. So this is another result, and I consider this result also for Tropilaelaps because long-term release is the critical point for the mites treatment. You can see my results, electron microscope results from the cage experiment. I create the Varroa bites artificially and also natural because we know the Varroa cytolate measurements. So I use some pins to create the Varroa bites, and also I use natural Varroa bites. And every day I take photos under the electron microscope. And also I measure the survival period after the bite wound, how long they can be survived. In 4 days, they are dying. The honeybees dying. So Turkish beekeepers confirm that, and they are always complaining about that. Just after our Varroa treatment, we lost some of the population. This is why we lost some of the population, because the chemicals or the all kinds of products can take the Varroa from the honeybees and cause the open wounds, and they get infections from these. And other results, this is the side effect of Varroa bites. In this study, we recognize that Varroa bites also cause the hairless honeybees. We reported in several years ago, we reported that hairless honeybees, yes, they lost their hair because of viruses. But after chitosan and oxalic acid application, we observed that hairs can create it by themselves again. So this is not only because of the virus infection, but also Varroa bites and Varroa wounds can cause the hair loss in adult bees. And also we measure the lifespan of longevity of bees, and in 9 days, the wounds naturally covered and repaired, but honeybees cannot be survived in 9 days because of bacterial infection. That's why we need to help them to cover of their wounds. Chitosan has also 2 important facilities. One, chitosan is antimicrobial activity, but not like an antibiotic, like a disinfectant. So not very strong antibiotic activities. So chitosan can have a disinfectant role for secondary bacterial infection besides the cover of wounds. And the second facility of chitosan is prebiotic. prebiotic means prebiotics eaten by beneficial microorganisms. So you can create a barrier under the chitin layer with beneficial microorganisms, not only the stomach or gut microbiome, also the surface of the honeybee. So this is also another point of this formulation. So
Asli, I'm
yes.
sorry, I interrupt
Yeah.
you. Can you end in 3 sentences?
Yes. In 2 minutes.
Thank you.
Sorry.
Okay,
In 2 minutes.
perfect.
I will finish it. Sorry.
Thank you.
Okay. So for Tropilaelaps and for Varroa, nowadays we advise the Turkish beekeepers long-term release formulation or long-term activity, because we need to do this. Otherwise, in each generation of Tropilaelaps, or it doesn't matter, Varroa, we face to some problems, not only the bacterial infection, but also the holes and wounds. It's the same for Tropilaelaps. After Tropilaelaps feeding, the broods like a bomb. So we call this symptom as a ball brood. If you observe some symptoms like full brood disease in your colonies, can also means that Tropilaelaps may be there, because after feeding by Tropilaelaps, all broods like a ball, seems like a ball. So please be careful for these symptoms that. And thank you for your attention, and thank you for time.
Thank you very much, Asli. Your presentation was very clear and very interesting. We will have now Jean-Marie Barbançon, who will speak in French, so you won't have the translate because it's the time for the translate to make a little break after the second interpretation time.
Yeah, sorry, no interpretation
Maggie.
into English because there aren't 2 interpreters and we have to take a break. Very sorry.
Je peux y aller?
Ah oui, du coup, voilà, on va accueillir maintenant Jean-Marie Barbançon, donc ancien directeur de la FNOSAD et vétérinaire. Voilà. Il va nous parler de Tropilaelaps.
Et apiculteur.
Et apiculteur, oui.
Oui, en fait, mon intervention sera courte. Je n'ai même pas préparé de présentation, puisque ce qui m'a été demandé, c'est de parler surtout de la réglementation qui pourrait être appliquée en cas de Tropilaelapsose. Donc, je m'en suis référé à la loi qui serait appliquée. C'est la loi de santé animale qui a été mise au point par les États membres de la communauté européenne. Voilà. Donc, en fait, ça a été changé depuis avril 2021. Elle s'applique donc cette loi depuis avril 2021. Jusque-là, chaque pays, chaque État membre avait un petit peu sa propre réglementation. On parlait de danger sanitaire de première catégorie, deuxième catégorie, troisième catégorie, en fonction de la gravité des affections. Donc, en fait, on se rend compte que Tropilaelaps a une gravité donc indéniable. Donc, si vous voulez, dans les catégories fixées dans le cadre de la loi de santé animale européenne, on a de catégorie A, catégorie B, catégorie C, catégorie D, catégorie E. Et donc, pour Tropilaelaps, c'est les catégories D et E qui s'appliqueraient. Donc, il a été question par Tropilaelaps dans l'intervention précédente. Donc, en fait, ça veut dire que les États donc, vont interagir auprès des apiculteurs et faire le nécessaire pour que, éventuellement, comme cela s'est passé à La Réunion, à l'île de La Réunion, avec notre ravageur qui est donc Edina tumida, dans un premier temps, si vous voulez, la lutte, ben, c'est la destruction, c'est le stamping out, hein, c'est la destruction des colonies atteintes, euh, destruction qui a ses limites en fonction des parasites et des particularités territoriales, il faut bien le dire. Donc, D, catégorie D, je précise, maladie pour laquelle des restrictions au mouvement s'appliquent entre États membres, donc nécessité d'un certificat sanitaire. Donc là, si vous voulez, j'ai bien entendu ce qu'a dit l'intervenante précédente, c'est qu'il faut faire très très attention au mouvement d'abeilles, puisque c'est par là qu'on a des risques. Et si vous voulez, c'est ce que j'ai écrit dans un article pour la revue de l'UNAF. Finalement, Tropilaelaps, bien sûr, il est plus près de la Turquie, mais on n'en est pas si loin non plus, puisque cet acarien est capable, par les transports, de faire du chemin très vite. Hein, donc, il y a de quoi s'inquiéter, puisque, bon, il peut y avoir des déplacements, des mouvements, des déplacements de ruches ou d'abeilles ou de rennes qui se font sans qu'il y ait une couverture nécessaire sur le plan de la surveillance sanitaire. Alors, catégorie D et E, ça veut dire qu'il y a une catégorie E, ça veut dire maladie soumise à surveillance. Donc, D et E, c'est, si vous voulez, le minimum qui pourrait être appliqué de toute façon par un État membre dans le cadre de la surveillance de Tropilaelaps. Ça ne veut pas dire que certains pays, États membres, puissent pas aller au-delà de ces catégories, hein, et pour accentuer encore l'effet de la surveillance. Hein, voilà, c'est à peu près tout ce que j'ai à dire. Je ferai un commentaire aussi pour avoir fait pas mal de bibliographies sur le sujet ces derniers temps. Je me rends compte que, effectivement, comme l'a dit l'intervenante précédente, Tropilaelaps, on a un risque fort de l'avoir, mais de s'en apercevoir que trop tard, et quand le mal sera fait, puisque c'est une petite bestiole qui n'est pas facile à voir, qui est rapide dans ses déplacements. Il y a quand même des vidéos qui circulent sur le net pour s'en rendre compte. Donc, il y a quand même lieu d'avoir des inquiétudes par rapport à cet acarien. Je crois que moi, si vous voulez, je suis d'une génération qui a vu arriver Varroa. Il était loin quand on a commencé à parler de lui, et puis finalement, on l'a eu en 82. Et donc, Tropilaelaps, finalement, il est aussi loin de nous, pour la France, hein, je parle, que l'était Varroa quand on a commencé à nous en parler. Et donc, il y a quand même de quoi s'inquiéter. Hein. Donc, en fait, je crois et je me désespère aussi du fait que on peut craindre que Tropilaelaps, pardon, puisse s'installer sans qu'on le voie de façon précoce. Ce qui met en échec les méthodes donc préconisées par l'État, savoir la destruction et tout. Parce que je suis à peu près persuadé qu'à partir du moment où il sera installé, ce sera impossible de l'éradiquer de toute façon. Hein. On a vu avec Varroa ce que ça a donné. Hein. Alors je crois que pour sensibiliser le monde apicole à ce parasite, cet acarien, il faut jouer donc sur le fait que cet acarien soit détecté le plus rapidement possible. Donc, l'intervenante précédente l'a bien souligné, et je crois qu'on peut l'en remercier. Et si vous voulez, par exemple, moi, pour les interventions que je vais faire sur le sujet, j'ai fait des montages vidéo pour que les gens voient bien à quoi ressemble ce Tropilaelaps aussi. Et donc, il faut sensibiliser. Et je remercie l'UNAF de s'inquiéter de ce sujet. Je crois que toutes les structures apicoles de France, et d'ailleurs aussi, doivent absolument sensibiliser les apiculteurs à ce risque qui est un risque majeur, à mon avis. Comme si on n'avait pas déjà assez de problèmes avec d'autres facteurs néfastes à l'apiculture. Donc, essayons de nous en garder. Voilà, c'est à peu près tout ce que j'aurais à dire. Hein.
Bah, merci beaucoup, Jean-Marie.
Hein,
Désolé
de
pour
rien.
le son. Donc oui, effectivement, c'est un très gros problème qui risque d'arriver beaucoup plus rapidement qu'on le croit, malheureusement. Et donc oui, effectivement, comme le disait Jean-Marie, faire attention aux importations de rennes, etc., et passer par des circuits où il y a des vérifications, c'est un des premiers moyens pour déjà repousser au maximum son arrivée, même si malgré tout, on ne doute pas qu'il finira par arriver. Pourquoi ne pas interdire les importations d'abeilles venues de pays contaminés? Du coup, je disais que les problèmes enfin, au niveau de l'interdiction de l'importation des abeilles venues de pays contaminés, c'est le cas au niveau européen. Mais le problème, c'est que le temps qu'on détecte la contamination, il y a déjà eu enfin, il peut déjà potentiellement y avoir eu des mouvements d'abeilles et donc des importations non voulues parce que comme on le montrait, enfin comme le montraient Asli et Jean-Marie, la détection c'est un des points noirs de l'arrivée de l'espèce et donc c'est difficile de repérer que l'espèce est présente et avant que ça soit déclaré, bah, il y a souvent un bon laps de temps. Et pendant ce laps de temps, bah, il y a des échanges possibles. Et j'ajoutais aussi que nous, une de nos demandes, ça serait que les pays limitrophes aux pays contaminés soient concernés par cette interdiction d'importation au niveau européen. Mais il y a très peu de chances que ce soit accepté, mais on a fait une demande dans ce sens.
Can I ask you a question in this way? It's
Yeah.
so it seems like it has a similar life cycle as Varroa does, right?
Yes.
Okay. And you said that the best measures to fight against it will be working with the oxalic acid, but in a different form than evaporation, right?
I would prefer the long term, not the evaporation. Evaporation is very effective method,
Yes.
but the rapid effectiveness, it has very high amount and rapid effectiveness. But Tropilaelaps needs to, you need in beehive, you need long-term efficacy against Tropilaelaps because they are randomly get out to the brood cells. And when you are applying the evaporation, you cannot be sure that if it is the get out production time of Tropilaelaps or not. So you cannot be sure about the time. So, but if you put some product in the hive and it's long-term release, means that you can always, even if they get out randomly, you can catch different time, the different Tropilaelaps population to fall down.
So in Turkey, you mostly apply chemicals. Are you working, for example, with techniques such as interrupting brood? You know, when you fully in the midsummer, you fully remove the brood, and then have you tried this technique as well?
Of course, sure. We always suggest the beekeepers that Varroa treatment or for Tropilaelaps, it doesn't matter, is an integrated fighting system, integrated management system or treatment system. What does it mean? In the springtime, you can use sugar powder to clean themselves. And also in springtime, you can use pollen trap. To clean the foragers outside the hive against Varroa. And also you can use brood interruption also for Varroa, because Varroa also use the brood areas, brood cells for production. But on the other hand, most of the beekeepers using these techniques, but in all over the world, beekeepers are more interested in chemicals, products, substances, herbal solutions, and propolis. And especially for Tropilaelaps, brood interruption is very effective technique, but migratory beekeeping is very popular in Turkey. The beekeeping is a culture of the countries. So their habit to move the colonies all the season. So to tolerate the capacity of the migratory beekeeping, you always produce your brood area. No options. Otherwise, after the second stationary, your colony is collapsed. But nowadays, I am the advisor of the plastic company. They produce cages for queen, and also they produce ring. We put the ring. We leave the ring to the abdomen. We cover the ring to the abdomen of queen, so queen cannot lay eggs inside the brood cells. So you don't need to caging the queen, because according to some scientific studies, caging methods disturb the queens and also limited the pheromones of queens. So when you caging the queen, the colony produce new queens, and you can see the queen cells immediately. So for pre-release of the pheromones, we are using some small rings put through the abdomens, but also we are studying on the side effect of this kind of rings to the spermatheca of queens, because the pressure of the ring may affect side effect of the spermatheca of the queens. And also we develop some other cagings, bottom side of the frames, not horizontal, the vertical one, and the big cage for queen. So you can use the pheromone as well, and also you can cage the queen at the same time. We are working on different kinds of projects for this.
Okay, and I'm not sure if I understood. So this might arrive to Turkey already, or is
No.
it not yet? So, but you're well prepared, it seems like. Okay.
Yes, we are on. Okay.
You're looking forward, I think. You're curious now, right?
Donc, vous avez des nouveaux projets. Oui, je suis convaincue que
most of the Turkish scientists are looking for Tropilaelaps in Caucasian area, but I'm looking for Tropilaelaps in west part, because in Caucasian area is isolated area, genetic conservative area, and the colony movements is not possible. But the wintering area of the Turkish seaside, it's more possible to find Tropilaelaps there. And I'm afraid of this. But so far in my field studies, I cannot observe it. And on the other hand, I couldn't trust the beekeepers that they report it, because they're afraid that government cannot support them. They don't want to.
I think it's not easy to detect as well if it's so small. And it's not like a mite. If it's just 1/3 of the mite itself, then
like a dust.
Yeah.
Okay, Varroa has a reddish color, red color. Why? Because Varroa synthesizes the melanin for protecting herself. And chitin and melanin together show a color. But Tropilaelaps live inside the brood cells. So Tropilaelaps like a cream or light brown, because they don't see the sunlight, and then they don't synthesize the melanin pigment. That's why it's light brown. So it seems like dust, very and the light.
And you think that the spread is favored by swarms or just buying queens from outside, or moving the colonies from far, or let's crossing borders colonies? For instance, if you bring some hives from Georgia to Las area in Turkey or Kachkar area, whatever, and then it might happen through
Yes.
this way, or okay.
Yes, yes, exactly. That's why we are afraid of it. And also in COLOSS executive committee, we have a member from Korea, and he said that he warned us that please, at the beginning, please don't try to treat Tropilaelaps. Please burn it, because in Korea, in 2005, the first report of Tropilaelaps in Korean bee colonies, and the prevalence of the infestation about 5%. But now it's 75%, 75% Tropilaelaps, and 95% Varroa together. Although they are using chemicals and organic compounds and also beekeeping techniques like interruption of brood.
Okay, thank you. Thank you very much for your presentation.
You're welcome.
We're gonna pass to Maggie presentation. Maggie, yeah. You can start to share your PowerPoint if you want.
Okay, 1 second. Can you see my shared screen? Can everybody see that?
Yes.
Perfect.
Okay, good. Good evening,
much.
everybody. Hi there. Thank you for inviting me to speak at your webinar. So first, let me talk to you about the life cycle of Tropilaelaps. So Tropilaelaps is indigenous to Asia, and it naturally infests colonies of the giant Asian honeybees, Apis dorsata. So here you can see a colony in the video, and there are some bees in the photo there. There are 9 different species of Apis honeybee in Asia, and Tropilaelaps can infest, parasitize, and reproduce in all of those species of honeybee. The European honeybee, Apis mellifera, is the only introduced non-native species of honeybee in Asia. So in these videos and photos, we have 2 of those Asian species of honeybee. So on the left, we have the Asian honeybee Apis cerana, and on the right, we have the red dwarf honeybee Apis florea. These are both native to Asia, and although they are not naturally not natural hosts of Tropilaelaps, they can be parasitized by Tropilaelaps. But these bees have co-evolved with parasitic mites, and they have developed natural defenses to deal with these mites and to deal with an infestation. The Asian honeybee Apis cerana is also the natural host and naturally infested by the Varroa mite. So to manage a mite infestation, these Asian honeybee species will do things such as abscond from their colonies. They also migrate over quite long distances, which means that they leave the brood behind when they abscond or when they migrate. They also frequently groom themselves to remove mites, and Apis cerana in particular, so the Asian honeybee, they will sacrifice brood that is infested with mite levels, and they will prevent that brood from emerging. Western honeybees are not naturally infested by any parasitic mite, so they have no natural defenses to these mite infestations, and this is why we see such high levels of colony mortality when they become infested. I've included a newspaper article here on the red dwarf honeybee Apis florea, and this describes how it was detected in Europe for the first time in Malta in 2024. Further details about that discovery are in this scientific paper, which reported this, and there is a QR code there that will give you a link to that paper if you'd like to read that. But this is significant because while we are concerned about our European honeybees transporting and spreading Tropilaelaps, all species of honeybee have the potential to spread Tropilaelaps. So I've included the life cycle here, and you are probably quite familiar with the life cycle of Varroa, but just briefly, a foundress female mite will go into a brood cell before that cell is capped, and she will hide in the feed underneath that larvae. And when the cell is capped, that Varroa mite will set up a feeding site on the larvae, and she will lay an egg, and that first mite that hatches out will be a male mite. She then continues to lay further eggs, and these subsequent eggs will be female mites. And all of these newly hatched out mites go through a series of molts until they are fully developed and until their exoskeleton is fully hard. The male mite will then mate with its female sisters, and depending on whether the original infested cell was a worker cell or a drone cell, they will produce. So from a worker cell, on average, you will get 1.6 viable Varroa mites, and from a drone cell, that's increased to 2.6 viable mites because drones take slightly longer to emerge from the cells. Tropilaelaps, however, they reproduce much more quickly than Varroa. They can mate outside of the cells, and the female mites can reproduce by parthenogenesis. So this means that they can successfully reproduce even if they haven't mated. And a female mite will, in much the same way that Varroa does, so goes into a cell before it's capped, and she will lay eggs, and these eggs will hatch and develop, and they will molt and have several sort of molts before they become fully developed. But because they reproduce more quickly, from a worker cell, on average, you will get 3 viable Tropilaelaps mites, and from a drone cell, this is increased to 4.5 viable mites. So I have included a video here, which I took in Thailand when I was working with Tropilaelaps mites. So here we have some Tropilaelaps mercedesi and some Varroa destructor, and they are on a honeybee larvae. And you can see from this video that the Tropilaelaps mites, they're about a third the size of a Varroa mite. So they are approximately 1 millimeter long by about 0.5 millimeters wide. You can also see that the Tropilaelaps mites are much quicker and more agile than the Varroa mites. So the big issue with any new infestation of Tropilaelaps is being able to identify that it is a Tropilaelaps infestation, because unfortunately the symptoms within a colony are very similar to the symptoms of a Varroa infestation. So you would see things like perforated cell cappings and a patchy brood pattern, dead cannibalized larvae and pupae with neglected brood. The adult bees will very often have deformed wings and stunted abdomens, and just generally the colony will be quite weak. The video I've included here shows you that it's quite difficult to see the phoretic mites within the colony. They are much smaller and faster than the Varroa mites, and they have a much shorter phoretic phase than Varroa mites. And the big difference seems to be the time which it takes a Tropilaelaps infestation to kill a colony. So anecdotally, beekeepers have reported quite high colony losses, so between 50 and 80% colony losses, and they're reporting that it can take between 2 to 3 months for a new Tropilaelaps infestation to kill a colony, which is significantly faster than Varroa would do that. So one of the reasons for this high colony mortality is the way that Tropilaelaps feed. So Varroa have piercing mouth parts, and when they are within the brood and reproducing, they will set up a single feeding site, or sometimes one or two feeding sites, and all of the Varroa mites within that cell will communally feed from this feeding site. Tropilaelaps, however, they use multiple feeding sites, and when they feed on the brood, they actually tear the brood. And you can see from this piece of research that where the researcher has dyed these feeding sites with blue dye. So you can see that there are multiple feeding sites on the brood. The damage from this feeding then goes on to become sort of scar tissue and deformities in the adult bees as they sort of pupate and then go on to emerge. And these deformities will shorten the life of the bee and have a negative impact on the colony as a whole. The bees are less able to forage and navigate, and just generally it affects the productivity of the colony. Again, I've included a QR code with a link to the paper that reported this research. So I've included a map on the distribution of Tropilaelaps. So as I said before, its natural host is the giant Asian honeybee, Apis dorsata, and that is in dark blue on this map. And the red area shows the current confirmed distribution of Tropilaelaps mercedesi. And in 2024, Tropilaelaps was confirmed for the first time in these new areas. And you can see from this map that Tropilaelaps has spread well beyond the range of its natural hosts. And it has been things like sort of migratory beekeeping, the sale of queens and things like that. But also Tropilaelaps will have spread on these other species of honeybee, such as the red dwarf honeybee. So in 2023, I worked on a project to test and develop screening techniques for Tropilaelaps to be used in the UK as part of our honeybee health monitoring scheme. So brood uncapping was a technique recommended by other researchers, and we trialed this and we found this to be very effective. We use a rhombus template to select 100 brood cells. Tropilaelaps don't seem to have a preference for worker or drone brood, so we selected worker brood quite a lot of the time. You can uncap either. We also found that as you uncapped the brood, if you gently blow over the top of the open cells that you've just opened up, very often that will encourage the mites to leave the cells, and you'll see them run out and kind of skirt across the top of the brood. The issue with this technique, though, is that it is quite time consuming, and the mites can be quite difficult to spot. So you do need good light, and you do need to be very observant to see them. Dr. ÖZKIRIM's new technique with using the wax strip to rapidly uncap the brood, that seems like a really good technique. It's not something that I've tried, but certainly seems a lot quicker than individually uncapping each cell by hand. So that's really good to see and really interesting, because I spent a lot of time uncapping brood looking for Tropilaelaps mites. So another technique that we used to use in the UK which is recommended in the scientific literature is the comb bump method. So this is where you would take a brood frame, you would shake all of the adult bees from the brood frame, and then bump the edge of that frame over a white tray to dislodge mites. We had a few issues with this technique. As you can see from the video, you have to use quite a lot of force to be able to dislodge the mites from the brood cones. And very often we would look at the frame and we would still see mites running around on the frame. We also found that the bump method killed the brood within the frame that we bumped. So we would go back into colonies 24 hours after doing this technique, and we observed lots of dead brood on the hive floor, and the bees had pulled out all of the brood from the frames that we had bumped. So we've actually stopped using this technique in the UK now because of that sort of destructiveness and the problems we had with killing the brood. We also trialed techniques that are used to monitor for Varroa. So we trialed things like an alcohol wash, CO2 monitoring, and an icing sugar roll of the adult bees to see if these techniques would be effective for detecting Tropilaelaps. And the alcohol wash and the CO2 monitoring, we found that these weren't terribly effective, which was quite surprising because for Varroa, that they're really reliable and it gives you a very good idea of Varroa mite levels within a colony. We think that this is because Tropilaelaps are just so much smaller than the Varroa mites that they don't become dislodged from the adult bees when they're in the alcohol or when they're in the CO2. We found with the icing sugar roll, though, the sugar would clog up the mites, so they wouldn't be able to hold on to the bees as effectively. And also the bees would groom themselves and that would dislodge the mites. And because the sugar is white and these mites are sort of brown, you can see the little brown dots in amongst the white sugar if you sort of shake it out. So this technique, it's quite quick and cheap and easy to do. It's also non-destructive. You can return the bees back to the colony once you've done it. So I would encourage beekeepers, particularly hobbyist beekeepers, if they want to monitor for Tropilaelaps, this is one method that they can use to do that. And finally, we also monitored natural mite drop onto sticky floor inserts. So this technique does work. You can detect Tropilaelaps in a colony with this method. However, the longer you leave the floor inserts into the colony, the more debris you will have on those floor inserts. And because the mites are so small and so difficult to see, it's very difficult to see the mites in amongst the floor debris. You need good lights, and ideally you would need a magnification sort of hand lens or a magnifying glass to be able to see them. We found that if we had more than sort of say 24 hours worth of floor debris, it was incredibly difficult to see the Tropilaelaps mites. So we published a paper on our work. We've got the results there. So like I said, we found that brood uncapping was very effective. We also found that the sticky floor inserts and the icing sugar roll were effective methods for finding Tropilaelaps. But like I said, the bump method, CO2 monitoring and alcohol wash wasn't terribly effective, unfortunately. So something else that I've been interested in is Tropilaelaps transmission. So how might these mites be spread around the world? An obvious route is through beekeeping and migratory beekeeping, people selling colonies, people selling queens. We need to be aware of those transmission routes. However, in the UK, so in 2022, we had a red dwarf honeybee colony, so Apis florea. They arrived on the side of a shipping container from India, and they arrived into Felixstowe docks. And fortunately, the workers at the docks kind of recognized this, and they reported this, and the colony was destroyed and sent to the laboratory for analysis. But that is just one colony that the port authorities have noticed, and we are quite concerned that there could be things coming in on shipping containers and boats and aeroplanes that can arrive in the UK that aren't being noticed. And this is probably how those red dwarf honeybees were introduced into Malta. So the photo that I have in the top right-hand corner of the screen is a box of Apis florea, so that red dwarf honeybee. So it's the honey, and this was illegally imported into the UK and also intercepted in 2022. So the photo underneath that box of honey is that red dwarf honeybee colony, and you can see that they store their honey at the top of their brood comb. They will attach their comb to small branches and small twigs, and then they have the honey at the top and then the brood underneath, and the brood is very close to that honey. So our concern in the UK was that when this box of honey arrived and was intercepted, potentially there could have been Apis florea brood in with that honey, and therefore Tropilaelaps could have also survived with this. So we wanted to look into possible routes of transmission a bit more. We carried out a project and we looked at what could Tropilaelaps might survive on. And we looked at lots of different things. And so we found that fortunately, Tropilaelaps mites, they were unable to survive on honeycomb for longer than 24 hours. So they couldn't survive for longer than 48 hours on the giant Asian honeybees. And what we saw was that their native host would actually groom themselves. They would groom the mites off. And when we looked at the mites, they actually had damage to them. So the honeybees had done things like sort of bitten their legs and damaged their body. However, we were quite concerned to find out that the Tropilaelaps mites could survive for up to 5 days on live European honeybees. And we use newly emerged bees. We're not sure, but we think maybe it's something to do with whether their chitin had hardened or not. We had about 15% of the mites live for up to 5 days on the Western honeybees. We also included dead brood and dead adult bees in the matrices that we trialed, and we had Tropilaelaps mites survive for 7 and 8 days on these dead pupae and dead bees. So this was concerning to us because this means that Tropilaelaps mites could potentially survive in sort of hive debris, in the bottom of a hive, in used beekeeping equipment, used beekeeping combs and things like that. Very often this equipment will be imported into the UK, and because live bees aren't present, there is no regulations around that, but it does seem that potentially some Tropilaelaps mites could survive in that. If you're interested in this work, we've published a paper on this, and again, the QR code will take you to that work if you'd like to read some more about it. So Tropilaelaps is a statutory notifiable pest, and different countries will monitor for it differently. So in the UK, the government agency, the National Bee Unit, it's who I work for, we monitor for Tropilaelaps, and we have bee inspectors, and we use these techniques, so the brood uncapping technique and the icing sugar roll, to carry out surveillance. And we also have risk points all around the UK, and these exotic pest risk points, so they're ranked based on the level of risk that they pose to the potential import of Tropilaelaps and also small hive bees, because we monitor for that as well. And close to these risk points, we have central apiaries, which are managed by voluntary beekeepers for us, and these central apiaries are inspected by the government bee inspectors 3 times a year. Beekeepers in the UK are also encouraged to monitor for Tropilaelaps. They can report anything suspicious to their local bee inspector, and they will come out and carry out an inspection. And beekeepers can also send in samples to the government lab for screening. And I think one of the differences between the UK and perhaps Turkey is all of this service is free to beekeepers in the UK, and we also offer a compensation service. So if we were to detect Tropilaelaps in the UK, and our policy would be to destroy colonies, but our beekeepers would be compensated for that. So there's a bit of a difference there in how we would manage. And like I said, it's a free service. If a beekeeper phones us up, we go out and we will offer them advice on the health of their colonies for free, which I think is pretty good, a good deal for the beekeepers. In the UK, we banned packaged bee imports in 2019 as part of Brexit and as part of leaving the EU, but we still allow queen imports from Europe. This is currently being reassessed at the moment. So Canada, for example, has now banned the importation of packaged bees from Ukraine because Ukraine is unable to establish if they are Tropilaelaps free at the moment. And this is something that we're currently reviewing as part of our government policy. So I'll just finish up my section now with a few points. So Tropilaelaps is spreading westward. It has arrived in Europe last year, and it's spreading in much the same way that Varroa did. So it's really important for beekeepers to be vigilant and to educate themselves and know what Tropilaelaps looks like and monitor for their bees. Like I said, brood uncapping is a very effective way to monitor. And Dr. ÖZKIRIM's method with the wax strips, that seems like a very good way to rapidly uncap a lot of brood to monitor for that. Also, icing sugar roll of the adult bees is a very sort of simple, non-destructive way that people can also monitor for Tropilaelaps. Thank you.
Thank you very much for your two extremely clear presentation. It was a pleasure to hear both of you. There is a question about the lifetime of Tropilaelaps in honey, in import or export honey. I think you said it, Maggie, but
Yes, so in the trial that we ran, we found that none of the mites in the trial would survive for longer than 24 hours on honeycomb or in just sort of liquid honey. Yeah, really sort of shortens their lifespan.
Michel, vous pouvez prendre la parole, par contre, bien sur le canal français. Michel, je ne sais pas si vous
Oui,
m'avez entendu.
oui,
Ah oui, ouais.
oui. En fait, c'était pour savoir si tout à l'heure, j'ai pas bien compris pour le traitement. Comme le Tropilaelaps semble avoir un temps phorétique très court, est-ce que j'ai entendu acide oxalique tout à l'heure, mais j'ai pas bien compris. Est-ce que l'acide oxalique du coup en flash s'agit pas tellement puisqu'il s'y rentre très vite dans le couvain. Enfin, j'ai pas bien compris si l'acide oxalique pouvait marcher ou pas.
Si j'ai bien compris que ça marche bien, mais qu'elle est plutôt la madame, attendez bien, j'ai oublié son nom, je suis désolé, mais elle m'a dit qu'elle favorise d'autres méthodes en fait. C'est pour ça elle préfère d'avoir d'autres méthodes avec le glycérine et qui n'a pas un impact très intense, mais qui fonctionne bien aussi en long terme. C'est ce que j'ai bien compris en fait.
Yeah.
But
Okay, we're going to have a translation of the question. They were wondering about
Asli,
the
just
oxalic,
to confirm, I asked
oxalic
you
acid.
about this method of using
They're speaking in English.
Vaporized oxalic acid, and I understood that you said it would work as well, but you prefer other methods which are not that intense or aggressive, let's say, and that's why you prefer the one with glycerin. Did I understand you right?
Sorry, I missed your sentences, your conversation at the beginning because the translator also is speaking with me.
No,
But
that's the conversation we had with you just before the presentation, and I asked you the method of vaporizing oxalic acid would work, and you said and the gentleman just didn't really understand. He could not follow our conversation, so he asked again. He was interested to know if this vaporizing oxalic acid would work or not.
Okay, vaporizing oxalic work in 3 days because this is the big pressure, rapid effective and efficacy and strong efficacy. But Tropilaelaps randomly get out and Varroa as well. So I would suggest the beekeepers long-term release oxalic acid. And Turkish beekeepers using oxalic acid dehydrate solution, pure solution, and 35%. And also for creating long-term release gel form, they put inside the glycerin to oxalic acid to make a gel form and long-term activity. But I claim that honeybees cannot use glycerin. You can get the same result with chitosan because chitosan also make the oxalic acid gel form and long-term release. So if you use a gel form of oxalic acid, more safety and more long-term affection. This is my idea. and my suggestion. But evaporation,
Okay.
yes, could work.
Ok. Donc, je pense que vous avez entendu, Monsieur Péchinon, parce que je viens de redemander en fait. C'était un peu ça ce que je disais.
Oui, tout à fait, oui,
Oui.
mais en fait,
Yes,
de
I
toute
understood
façon, en France, on utilise l'acide oxalique en
your answer,
sublimation
but
que
in
pour le
France,
couvain, quoi. Alors, je ne sais
we
pas si en
use
Turquie, ils
oxalic
ont
acid
des
when
mamans
there's
où il n'y a
no
pas de
brood.
couvain. Ça, je ne sais pas.
Yeah.
Et
In
puis,
COLOSS Association, sorry. In COLOSS Association, we have a task force only working on Varroa treatment in different regions, in different countries, and in different temperatures. So we found that, according to our results, formic acid effect on Varroa by evaporating, yes, vapor of the formic acid. But oxalic acid effect on Varroa by contact. So we set up standard experiment in Israel, in South Africa, in Sweden, Switzerland, Turkey, Italy, France, and in different temperature, we found that if you make a gel form, you cannot be limited by temperature. You can use the gel form also in brood season because gel form is slowly released, not by evaporation, by contacting the bees to fall down Varroa. This is the newest findings of our experiments. Not the oxalic acid solution or evaporation, because evaporation can damage the broods. So yes, in Turkey, we prefer the broodless period for oxalic acid evaporation or formic acid using, because it is also evaporating. But gel form, we only consider moisture level in the hive. That's why in spring, early spring or winter time, we use the gel form by dropping method, typical 5 ml in each frame. In nectar season, in summertime, we use spray form of gel, and in autumn time or late spring, we use wipe handkerchief form. I upload the gel form of oxalic acid to the handkerchief, the cotton handkerchief, and I put the wipe handkerchief on the frame. So by this method, I also prevent the higher level of moisture in the hive, because we don't prefer the high moisture level in hive to protect bees from the fungal infection.
donc, en France, on n'a pas d'AMM de toute manière pour cet acide oxalique et on craint surtout l'apparition de résistance a priori, on a évité depuis
very
plus de
worried
40
about
ans en
resistance.
utilisant l'acide oxalique en flash.
And when we use oxalic
ça me fait un peu
acid
peur d'utiliser cet acide oxalique
as a flash
parce que
treatment,
si on a des résistances aux
I'm kind of
ingrédients,
afraid to use it in that way, because
on n'aura plus
if we have
grand-chose quoi, avec les résistances qu'on voit
resistance,
également
we won't have
avec
many
les
other
herbicides
weapons or
synthétiques.
arms that we can
Mais c'est
use.
intéressant.
But it's interesting what you said.
Yes, actually, for the biosafety, organic acids can be used for organic beekeeping in Turkey. For it's allowed by the government, and also we have minimal residue problem in with organic acids, comparing with the chemicals like coumaphos, like amitraz, like flumethrin. That's why we don't expect Varroa to gain a resistance against oxalic acid. And also long-term, from this side, the long-term use also beneficial for residues and also resistance to Varroa. Because long-term, the slowly release, the more safety for the side effects, not only resistance, but also residue, we recommend the beekeepers.
Certes, il n'y a pas de résidus, mais n'empêche que si vous
Well,
mettez
certainly,
pendant deux mois des linges
there's
acide
no
oxalique,
residue, but if you leave a handkerchief
en tout cas, il se pourrait
or
qu'apparaissent des résistances.
a wipe with oxalic acid for a long time, if it's a question of months, then maybe resistance could develop.
Yes, but there's no paper about the resistance of Varroa against organic acids so far. And also another, on the other hand, you leave the wipe on the frame for only 10 days and then get out. But the efficacy of the wipe in the hive takes more. This is the critical point according to my field study. So this product now registered in Turkey, Serbia, Slovenia, Azerbaijan, Austria, and Germany. So this is preferable. Evaporation of oxalic acid also leave some white crystals after the evaporating. So this is also may cause the residue problem. So it depends on the beekeeper's preference.
Okay, merci.
Right, thank you.
Okay, you're welcome.
A question for Maggie. Do we know if there is a place in the world with only Tropilaelaps and no Varroa?
We don't know so far, but we know that there is no habitat competition between them, like Nosema serrana and Nosema apis, because they have different biology, and the generation multiply or generation numbers are totally different. So on the other hand, I saw another question I would like to answer. Somebody asked that in Asian country, how the Apis dorsata can fight the Tropilaelaps. Please remember that parasites and host, they have co-evolution. So any kind of parasites doesn't want to kill their host because they cannot be survived without their host. So for natural hosts, Tropilaelaps not very aggressive, but Apis mellifera is not her natural host. So we have to wait for the co-evolution, adaptation between Apis mellifera and Tropilaelaps, but it would take several years, so we have no time, and probably we would lose millions of colonies. Maybe Maggie will would like to answer or add something.
Yes, I mean, I think unfortunately, in every country where we have European honeybees present, and North America, South America, where we've introduced them, unfortunately Varroa is now present in all of those countries as well. Australia, so 2023, they recently had Varroa arrive there for the first time. So I'm not aware of any areas or regions where you just have Tropilaelaps without Varroa. But as Dr. ÖZKIRIM said, Apis dorsata, the natural host, so they have co-evolved with Tropilaelaps. They have this natural defense to them, and even the other Asian species of honeybee, they all have parasitic mites. So they will do things such as grooming themselves. They abscond from their colonies, and they will migrate. So that they have co-evolved, and they have developed these evolutionary techniques to be able to cope with Tropilaelaps and other mite infestations. And our Western honeybees just simply don't have that natural resistance to mite infestations, unfortunately.
Another question.
Yes, there's another question.
On sait que la Chine produit beaucoup de miel, et
We know
notamment
that
elle produit du miel
China
à partir
produces
également
a
de
lot of
colonies européennes
honey,
de Mellifera. Donc, comment
and
ils se débrouillent, les Chinois, parce qu'ils devaient être
how are they
très embêtés avec ces
managing?
Tropilaelaps. Alors, j'ai pas entendu parler qu'il y avait des chutes dramatiques de colonies en Chine.
I haven't
Pour
heard
le,
about any sort of
pour le
dramatic
Mellifera,
colony collapse or things like that
ou
in
des
China.
déforestes, des choses comme ça.
How did they manage with these?
Maggie, would you like to answer, or may I answer it?
I'll give a quick answer, and then perhaps you can join in. So as far as I'm aware, in China, so it's not kind of widely reported, but the Chinese and lots of Asian countries, so they will just continually use either synthetic treatments, so amitraz, fluvalinate, flumethrin, coumaphos, and they use these treatments permanently in their colonies. That it's not, they don't use them in the same way that Western beekeepers do, where they have a treatment regime and they follow the instructions on the packet. Yeah, and unfortunately, that there is miticide resistance. So Tropilaelaps have become resistant to a lot of those chemicals in sort of Asia. Things like oxalic acid and formic acid, because they are organic acids, it's unlikely that the mites will be able to develop a resistance to them. But I think just sort of because of the the political situation in China, they're reluctant to report sort of issues that they have. So it's difficult to get an accurate representation of what is happening in the country.
Yeah, and also they have many colonies, so statistically they don't they care, but they don't report, and they say, okay, it would be normal, and they continue to use chemicals to keep their colonies. So beekeeping is different culture, directly depends on the countries. So beekeeping is a culture. For instance, in Turkey, Turkish beekeepers play the colonies like a ball. They play the colonies, and they always want to treat the colonies by some substances. And I advise them natural selection. Please keep strong and healthy colonies and leave others. But it's totally cross our culture, Turkish culture, because they want to care. It's opposite side of our hospitality. So we are emotional. But the Chinese culture is different, and French culture is different. So in COLOSS Association, we have also BRAP task force about beekeeping structure in different countries, and bridging between scientists and beekeepers, because some of the beekeepers not actually trust the science directly. They always want to make experiments by themselves in hives. So they offer me, Asli, okay, give the solution to me and I can try the solution in my hives. And I said, this is my task. Doing experiment, this is my task. Your task is application. So, and all over the world, I think the story is the same, but the culture is different.
Thank you for your answer. Another question: do we know the threshold of Tropilaelaps in order that bee colonies can cope with it?
I don't understand.
Yeah.
Oh, God.
I don't know how to pronounce it, but we know,
Isabella's question. Do we
yeah,
know the threshold of Tropilaelaps in
Yeah.
order that bee colonies can cope?
Yes, they can cope.
Okay. Actually, it depends the colony population level and Tropilaelaps level, I think. So in different conditions to be together to make an assessment like this. I don't know. I have no idea. What about Maggie? Do you have an idea?
I think that the main issue with Tropilaelaps is that it reproduces much more quickly than Varroa does. So a low level of infestation can very quickly become a high level of infestation, particularly if beekeepers are unaware and they don't treat the colonies. So I've done some work in Asia, and we had some honeybee colonies which we didn't use any treatment at all on them, and by sort of 6 to 8 weeks, the colony was at the point of collapsing, and we had to step in. So it really is a rapid progression of symptoms within the colony. So I don't think there is necessarily a threshold of Tropilaelaps mites that Apis mellifera can cope with, I think, unfortunately. So with Varroa mites, when you have a Varroa infestation, if you don't treat the colonies will continue to survive. They won't be very big colonies, they won't be very productive colonies, but you will still have a colony of live bees, and they can go on for sometimes several seasons before they succumb to that Varroa infestation. But with Tropilaelaps, it's probably sort of 3 to 4 months would kill a colony, and it's very alarming to see that sort of firsthand, and to see the progression of how quickly it will actually sort of damage a colony. So yeah, I don't think there is, well, currently the Western honeybees haven't developed any sort of resistance to the Tropilaelaps mites, so that there isn't a kind of a base level of mite infestation that they can tolerate.
And it's not Asian Tropilaelaps now, it's European Tropilaelaps, because she tried to adapt the European honeybee. So that's why she's aggressive. And I consider Tropilaelaps as the bacterial version, mite version of American full brood. American full brood, similar like Tropilaelaps, for the rapid and quick reproducing and resistance and aggressive. So that's why this type of Tropilaelaps will collapse our European colonies very quickly. This is what we know so far.
One question for Maggie: do you test Keto too? And the second question.
Yes.
It's in the chat, so you can answer directly if you want.
Yes, you're welcome. And please don't wait till August.
Okay.
And in every brood season, please use the brood interruption and also monitoring methods in your hives. And I advise the keep record, the video method. It's more time saving method. I call this time saving because, like Maggie said, other methods is time consuming.
Yeah, so in the UK, we are advising our beekeepers to do exotic pest monitoring in their colonies. We say 3 times a year, but I think in reality, we would like beekeepers to do more than that. It was just, finding something that beekeepers would be happy to do. But I think, if Tropilaelaps were to arrive in, France or the UK, then it's as they do in Asia, it will require continual treatment of the colonies to be able to sustain those colonies and keep them alive. So it won't be treating every 2 months. It will be perpetual prophylactic treatments that will be needed in the colonies, and it will be a big change to the way that we keep bees in the West. So Asian beekeeping is very, very different to European and North American beekeeping, and part of that is because they have always kept European honeybees with Tropilaelaps, and the colonies are smaller, they don't do as well, and that's because of the Tropilaelaps mite infestation. The beekeepers that we worked with in Thailand had a lot of issues, so they couldn't sell their honey to bulk honey buyers because of the contamination from the chemicals that they have to use to treat for Tropilaelaps. So they get a very low price for their honey because it's contaminated. And a lot of them are subsistence farmers, and they rely on this money to come in. But when you test the honey, it is quite sort of heavily contaminated with things like fluvalinate and amitraz and things like that, because they're trying to control the Tropilaelaps mites. So it will, if Tropilaelaps do arrive in sort of Western Europe and France and the UK, it will have a very big impact on the way that we keep bees and have to manage our colonies. It will be completely different to what we're doing now.
Mais je n'ai pas bien compris pourquoi la rupture de couvain par encagement marchait moins bien chez Tropilaelaps, puisque
brood breaks by caging the queen
il a une survie
didn't work
quelques jours
as well, because
Donc,
if
si on fait une
it can only
rupture
survive a few days
couvain
without
avec un encagement
brood,
de 1 mois, ça devrait au moins aussi bien marcher que pour Varroa.
a brood break should work just as well, or removing male brood as well should work just as well as with Varroa, right?
Sorry. For instance, in one province in Turkey, there is 1 million colonies in one location. Okay, if you can use brood interruption techniques, but another beekeeper don't use. So you take the action totally all together at the same time. Otherwise, Tropilaelaps can be survived another colony, another apiary, and all apiaries is very close to each other. And also you change the frame from strong colonies to weak colonies. Beekeepers also move all the time, and also they change the frames inside between colonies and the apiaries. This is the main problem. You are not alone in nature. This is the problem, especially the crowded area.
En fait, la vitesse de génération du Tropilaelaps nous rattrape, si je comprends bien.
So if I've understood correctly, the speed of their development, they're catching up with us.
1 mois après, après l'engagement, eh ben, à nouveau le Tropilaelaps, il se développe.
If the queen is caged, and then a month later Tropilaelaps is back again, the brood break would not be sufficient. Is that right? Sorry, that was his question.
I think brood interruption and queen caging are sufficient methods. This is social problem. The social problem is they didn't apply the techniques at the same time. This is the problem. Not come back again. Tropilaelaps may come back again because of the swarming or the, colony, sell and buy and something like that. If we are alone and small apiaries, the two techniques works very well.
Okay.
Okay. Maybe a last question, and after we end the session, if you want. But the question about formic acid in the chat, if you.
Isabella. I like Isabella.
Has formic acid been used against them because it goes through the brood cap? Is the question.
Yes. I have a paper about it, not for the Tropilaelaps, but also Varroa, because formic acid goes through the brood caps. But also we report the side effect of formic acid. Formic acid evaporation capacity is very high, and formic acid burn the trachea of honeybee. So inside the hive, you cannot recognize it, but the first fly of the honeybee outside the hive, honeybee has gone, but not come back. So beekeepers think that this is nosema infection. Now, this is formic acid side effect, because formic acid burns the honeybee's trachea. For brood cells, sometimes it causes some of the broods as well. This is the side effect. If you accept this side effect, yes, it works very well for also Tropilaelaps. So in this spring, I think, not spring, on February, I will be in Georgia, and I will test chitosan, oxalic acid, formic acid, in different doses and different application. But I focus on not only efficacy of the product, but also safety of product, because I'm more interested in the side effect of the products on honeybees, because we have to make sustainable beekeeping, not only kill the varroa. It's not enough. You also keep the survive for your bees. This is the critical point. This is my point of view. And Maggie, it's your turn.
Yes, I mean that there's been quite a few bits of research that have used formic acid for Tropilaelaps by, I believe, Dr. Samuel Ramsey and Dr. Jeff Williams. So that they both published papers on that. Unfortunately, I don't have them to hand, but I'm sure if people are interested, if they Google them. So yeah, I mean, formic acid is an effective treatment for Tropilaelaps, but as Dr. ÖZKIRIM said, it can have side effects. We've had reports of queen losses from formic acid use in the UK, so that can be an issue. So it is important that you're not harming the colony in a different way whilst you're treating these mites.
The last question, maybe Asli, you already answered it in the chat. It's about chitosan and the recipe and how to use it.
The last question was, can we know more about chitosan, please? What's the recipe? Who uses it? How to use it?
Yes, it has a patent. And also, I'm against the homemade or beekeeper-made solution. It's not the beekeeper's task, and it's a trademark, and it's called as chitoset, and produced by the Turkish company, and also export to the European and the Balkan countries now. And only the registration procedure needed to be completed in each country. So that's why I cannot explain the percentage of the recipe, Also, chitosan is a very, expensive product because it gains isolated from the Crustacea family in the sea. I don't know how to in English. I wish, Maggie, to speak my native language, mother language like you, but sorry for my English. Crustacea in
Yeah, crustaceans like crabs and
crabs, yes. So they collect high amounts of crabs and isolate the chitin from them, and then the acetylation. That's why this is the very expensive substances for beekeepers in homemade solution. So this is the trademark, and it's called as chitosan. I'm sure it will reach you soon to France. Maybe in England, I don't know. Nowadays, Jeff Pettis and Jeffrey Williams is testing on Varroa and also Tropilaelaps, and in South Korea, and also but in Turkey and Balkan and some countries, it's registered.
So we will see in France if it will be registered too. Thank you very much again for your presentation.